Begin by completing the tables. Here I see 6 divided by 6 would give me 1. So 240 divided by 6 would tell me what goes in this blank section. Well, I know 6 fits into 24 4 times, but it's not 24, it's 240, so it should be a 40 there. Then to get from 40 to 1, we could divide by 40. Well, 1 divided by 40 is just 1/40th. Complete the remaining 2 tables. You can pause here if you need to, and then move on when you're ready. Suppose you ride your bike from 8 a.m. to 8 p.m. at a constant speed. About how long would it take one of the world's fastest sports cars to travel the same distance? Well, from 8 a.m. to 8 p.m., that's 12 hours. We would expect the car to travel a lot faster than we would on a bike, so it shouldn't take the car 12 hours to go the same distance. But we don't know how fast the car travels. We don't know how fast you rode your bike. We also don't know the distance that you rode your bike in those 12 hours. So from here, it's mostly just a prediction. We would need more information to be able to narrow it down. This double number line represents the ratio relationship between the number of miles and the number of hours that Blake rides his bike. What is Blake's speed in miles per hour? Here I have 3 hours, but if I split it up to figure out how many miles per hour, we would want to know how many miles in 1 hour. 45 split into 3 sections is 15. 15, 30, 45. So he can go 15 miles in 1 hour. At this speed, how many hours does it take him to ride 30 miles? Well, we can see here 30 miles would take him 2 hours. At this speed, how many miles does Blake ride if he rides his bike for 5 hours? If we continue to add 15, 45 plus 15 is 60, plus 15 more would be 75. We also know that he travels 15 miles in 1 hour, so we could multiply by 5 to figure out how far he goes in 5 hours. 5 times 5 is 25. 5 times 1 is 5, plus 2 more gives us 75. So there's a different strategy to get the same answer. The ratio table represents the relationship between the number of miles and the number of hours that Kelly rides her bike. Who rides faster, Kelly or Blake? Well, I see that Kelly can go 64 miles in 4 hours. So to find the unit rate, we can divide. 64 divided by 4. 4 can go into 6 one time. 6 minus 4 is 2. Bring down the 4. 4 fits into 24 6 times. So Kelly rides at a rate of 16 miles per hour, and Blake rides at a rate of 15 miles per hour. This would mean Kelly is faster. MPH stands for miles per hour. Since 16 is greater than 15, that means Kelly goes farther in the same amount of time, so she is faster. All right. Here we are looking at the unit rate. For bike rentals, we have $96 every 8 hours. So our goal is to find the rate in dollars per hour and then the unit rate. To find the rate in dollars per hour, we want to change this to be 1 hour. So we have to divide by 8. 8 can go into 9 once. Bring down the 6. 8 fits into 16 2 times. So the rate in dollars per hour is $12 per hour. But the unit rate is just the number, just 12. The rate includes the units. The unit rate is just the number. Right, for the next one, we have $72 for every 6 hours. So to figure out how much it is for 1 hour, we would divide by 6. 6 belongs in 7 once. 7 minus 6 is 1. Bring down the 2. 6 can fit into 12 2 times. The double number line represents the ratio relationship between the total cost in dollars and the number of gallons of gasoline. What is the rate in dollars per gallon? The way that they write this tells us the order in which we divide. So this is dollars divided by gallons. So we're going to take the dollars and divide by the gallons. Make sure your decimal is lined up. 5 doesn't fit into 1, but it fits into 13 2 times. 2 times 5 is 10. 13 minus 10 is 3. Bring down the 5. 5 fits into 35 7 times. So we have 270. And then we interpret it. That is $2.70 for 1 gallon of gasoline. The unit rate, remember, is just the number, so 2.70. At this rate, what is the total cost to fill a 26-gallon tank with gasoline if it is empty? If it's $2.70 per gallon and we want 26 gallons, we can multiply. 7 times 6 is 42. 7 times 2 is 14. Plus 4 more makes 18. Put in that 0. 2 times 6 is 12. 2 times 2 is 4. Plus 1 more makes 5. If I add those up, I get a 2, a 10, 5, 6, 7. And my question had 1 decimal place, so my answer needs 1 as well. The total cost to fill a 26-gallon tank is $70.20. A driver spends a total of $24.30 on gasoline. At this rate, how many gallons of gasoline does the driver buy? Well, at a rate of $2.70, if they bought 10, that would put us at $27, so that's too much. Let's try 9. 9 times 0 is 0. 9 times 7 is 63. 9 times 2 is 18. Plus 6 more is 24. We had 2 decimal spots in the question, so we need 2 in our answer. So they can buy 9 gallons. The way we could figure this out by working backwards is $24.30 divided by 270, and that would also give us 9. Una types at a constant rate of 2 minutes per page. Her computer teacher, Miss Song, types at a constant rate of 2 pages per minute. Complete the ratio tables. We're going to use this ratio pattern all the way down the table. In the pages, we're counting by ones. In the minutes, we're counting by twos. Over here, in the number of pages, we're counting by twos. And in the minutes, we're counting by ones. How many pages can Una type in 50 minutes? What about 100 minutes? Well, we know she types 2 minutes per page. That means for one page. In 50 minutes, to get to 50, we would multiply by 25, which tells us she can do 25 pages in 50 minutes. To get to 100, we would multiply by 50, which would indicate that she can do 50 pages in 100 minutes. What is Una's rate in pages per minute? She types 1 page in 2 minutes. So if we want pages per minute, we would need to change the minutes to 1 by dividing by 2. 1 divided by 2 is 1/2. So her rate in pages per minute is half of a page per minute. The unit rate would just be 1/2. How many minutes does it take Miss Song to type 50 pages? How about 100 pages? Well, it takes her 1 minute to type 2 pages. So if we wanted 50 pages, we would multiply 2 by 25, which would tell us it takes her 25 minutes to type 50 pages. If we wanted 100 pages, we would multiply 2 by 50. And we need to do 1 times 50 as well. So it would take her 50 minutes to type 100 pages. What is Miss Song's rate in minutes per page? Well, it took her 1 minute for 2 pages, but we want per page. So that would be 1 page. We'd have to divide by 2. 1 divided by 2 is 1/2. A half a minute per page. The unit rate would be 1/2. Notice this is minutes per page, and this one was pages per minute. The graph represents the ratio relationship between the number of cans of peas and the total cost in dollars of the cans of peas. Write a ratio that relates the number of cans of peas to the total cost in dollars. What is the rate in cans of peas per dollar? What is the unit rate? Okay, so we're writing our ratio of cans to cost. Here I see a point at 5:2. So 5:2. What is the rate of cans per dollar? If we want per dollar, that would be for $1. So we need to divide by 2. 5 divided by 2 can be written like this, or we can change it to a mixed number, which would be 2.5. The unit rate would be 2.5. In part B, we are writing the ratio that relates the cost to the cans. So the cost was 2 and the cans was 5. What is the rate in dollars per can? So this time we're dividing by 5. $2/5 per can. The unit rate would be 2/5. We could also change that to a decimal and it would be 0.4 or 40 cents per can. Then it says, what would the total cost of 8 cans of peas be? If it's 2/5 per can and I want 8 cans, 2/5 times 8 would tell me how much it would cost. 2 times 8 is 16. There's an invisible 1 under every whole number. 5 times 1 is 5. I know 5 can fit into 16 3 times, because 3 times 5 makes 15. And then I'd have 1 extra. $3.25. That's also $3.20. How many cans of peas can someone buy for $8? This one we would work backwards. So we have $8, but we know that it was 2/5 per can. Or we can think of it as it is $2.50 or 2.5 cans per dollar. So we know 2.5 cans for $1. And we want $8. So we're going to multiply by 8. 2.5 times 8. Well, 2 times 8 is 16. 8 halves would be 4. So 2.5 times 8 is going to be 20. They can buy 20 cans for $8. You might also see, well, they can buy 10 cans for $4. So if we double that, giving us 8, and 10 doubled would be 20. I'd like you to try this one on your own. So go ahead and pause here and attempt it in your workbook. All right, now that you have had an opportunity to try it, I'm going to reveal the answers. The rate the auto racer drives the sports car is 300 miles per hour. So the unit rate would just be that number 300. Based on the graph, what is the rate the auto racer drives the sports car in hours per mile? That would be the other way around. So it would be 1 over 300. Suppose you could ride your bike for 12 hours at a constant speed of 15 miles per hour. How many hours would it take the auto racer to drive the sports car the same distance? So if we did 12 hours at 15 miles per hour, we would multiply those to get 180 miles. Well, we know that the auto racer can complete 300 miles per hour, so it's going to take him less than an hour to complete that distance. You can see here, they multiplied 1 over 300 by the miles, and they found out that it would take him 0.6 hours to drive the sports car the same distance that we would ride our bike. So significantly less time than it would take us. Make sure your warm-ups are complete and your workbook is filled in.